Hello everyone, welcome to the second half of the video. We're on question 3 and that means 4 questions in total, so 2 more questions to go. Again, I really like this question. It draws on lots of your knowledge and starts off by saying a pupil is investigating current, potential difference and resistance in a parallel circuit. We'll see that in a sec. There's a figure below which shows how he set this circuit up. It's got 2 resistors in parallel, so let's have a look. There is resistor 1, resistor 2, there's a voltmeter around each resistor, and there's an ammeter in each branch of the circuit. Now, I've done an annotation over here. The reason is, well, this is always helpful, but it will become clearer very shortly when you see what the question is asking you to do. So it wants you to complete the sentences about current and potential difference in the circuit, choose from the correct answer in the box. So just so we're really clear, A is going to be ammeter 1 and ammeter 2. V is voltmeter 1 and voltmeter 2, and you've got various combinations of the ammeters and voltmeters here. So adding the 2 values of the ammeters, subtracting the values of the ammeters, saying that they're equal, and then the same for the voltmeters as well that measure the potential difference. Now, you need to know these rules when it comes to looking at circuits and thinking about current, potential difference and resistance, which we'll look at very shortly. So when you know the rules, it becomes a lot easier. The first question is, the total current from the battery is, well, it wants to know the total current from the battery. So if you knew that in a parallel circuit that current splits, then the current is going to come out. It's actually been connected a slightly different way, so positive signs that way and the negative signs that way. Current comes out. It's the flow of coulombs of charge, so it comes round. Some then goes that way, some goes round here to this ammeter, so it's split. The current is split. Yeah, that's what a parallel circuit is. It's a circuit where current can go one of 2 ways, and the total current coming out of the battery is going to be a combination of this one and this one. So the answer is A1 plus A2 would give you the total current there. So if I put a third ammeter in, A3, that would equal that one plus that one. It would give you the total. Okay, so the next one is, and I just need to add something because I tip-X'd it out and then forgot to write it back in, is an equals sign. There's an equal sign in there. It's V1 equals V2. The potential difference across the battery is going to be the same as V1 and V2. Why? Look at the rules. In a parallel circuit, voltage stays the same. So you're going to have, or potential difference is the other term for voltage. You have the same potential difference here as you are here, as you are here. So potential difference across the battery, it's the same as V1 and V2, so therefore they equal each other. Those are your 2 answers there. Alright, so 3b wants to talk about the resistance. It's a parallel circuit, so you need to remember your rules for resistance and parallel circuits. In a series circuit, it's the sum of the resistances. In a parallel circuit, it's less than the lowest resistor. Alright, so read the sentence. The effective resistance of the 2 resistors in parallel is, as I've said, less than the sum of R1 and R2. So you might say that this one is 10 ohms, you might say that this one is 20 ohms. Because they're in parallel, 1 branch, 2 branch, the total is going to be less than 10 ohms because it's lower than or less than the lowest. C. So just looking at this graph first of all, we've got temperature on the x-axis, resistance on the y-axis. As temperature increases, resistance decreases. You see that because the line is going down. It's going down in a curved way. So as temperature increases, resistance increases a lot. And I've just made that note there. It wants to know the name of the component that does this. Right, the name's a thermistor. So thermistors respond to temperature, and the opposite happens. So if temperature increases, resistance decreases. For question 3C part 2, He wants to know the pattern. Well, we've answered half of it already. As temperature increases, resistance decreases. That will get you your first mark. Get a second mark for saying they're not directly proportional. We can tell that because this is not a straight line. It doesn't go through the origin, so it's not a directly proportional relationship. It's curved. Right, question 4. Some calculations here. So underline, label. It helps with every single calculation. Write down the equation that links charge flow, current and time. You can often see it as current equals charge over time, I equals Q over T, or you can see it as Q equals I times T. Either one is fine, no problem. Okay, so it wants you to calculate the charge. We've got the equation to do that. List values. Right, the ones that you need here are going to be the current and the time. You don't need potential difference just yet, because that's not in the equation. You will need that in the next question, so that's why it's given, but you need to be selective with what you're picking. You've got current 4 amps, time 30 seconds, charge is, we don't know, that's what we're trying to work out. The equation, we're going to use Q equals I times T, or you could use that and rearrange it, but this one's a bit easier. 4 times 30 gives you 120. You get 2 marks for getting 120, you get a third mark for writing coulombs, which is the unit for charge. And last point, last question. It wants to know the energy transferred in 30 seconds. It wants to give you answer in standard form, and it wants a unit. Alright, so energy transferred. You need to know the equation for that. The equation for energy transferred is voltage, and this is how you learned it, or potential difference equals energy divided by charge, right? And then at a later stage you'll need to rearrange that. You could do it at this point. You could go energy equals potential difference times charge, but we'll leave it as that for now. That's how I've worked it out anyway. You've got your potential difference from before. That was 200. Let me refocus, and 30 volts. Let me just show you where that was. It's there, it's given to you there, and I labelled that, so I'm clear. The energy we don't know, that's what we're trying to work out. The time, well, we don't need it for this calculation, but it just tells you that what's happening is the same as in these old questions, because the time there was 30 seconds. You need the charge, and we worked that out. Well, you should have worked it out in your last question here, of 120 coulombs. Now, if you substitute those values in, you get 230 over 120. That means energy equals 230 times 120, right? So voltage multiplied by charge gives you the energy. Now, I've made a mistake here. I've just realised I haven't written my answer in standard form, right? So I would have lost a mark there, which is no good, but I will correct it for you. 2.76 times 10 to the 4. That would be good for 3 marks, and your 4th mark would be for writing joules, because that is the unit for energy. Alright, easy to make these silly mistakes, so make sure you're reading the question. And I did underline it, but I must have been in a bit of a hurry when I was doing it. So there you go, don't make the same mistake as me. Alright, have a good weekend. Thank you very much.